All right, so who do you agree with? Mario. Why? Because he's Mario. Good reasoning. Solid, solid. But like, why? How would you go about solving this before you like start telling me who you agree with? How would you go about solving this? Simplify. All right, so let's simplify the 12. What do you get? Everybody, right there. 6 and 2. And then break this down. 2 and 3. And we got a pair of 2's, right? We're going to pull out the 2 up to the front. So that's going to give me 4 radical 3. Now, remember, perimeter is add up all the sides, right? So if this is 4 radical 3, this guy's going to be 4 radical 3. All right, now we're going to simplify this guy. What does this break down into? 3 and 9. And 9 breaks down into 3 and 3. We got a pair of 3's. I'll pull it out to the front. So that's going to give me 9 radical 3. Let's see where I did that. You got to be able to simplify. Go ahead. For the 9, what do you mean adding? Yeah, we multiply by it out front. Cool. Okay. Now this is 9 radical 3, then this guy's got to be 9 radical 3. What did we learn yesterday about adding radicals? What did we learn? What was the most important thing? Wrote it in all caps. No. Exactly. So are all of these the same? Like underneath the radical, are all of them the same? Yeah. So we can add all of these up, right? So we're going to add up the outside. Okay, so what's 9 plus 4 plus 9 plus 4? What's 9 plus 4? Yeah. Okay, so 9 plus 4 is 13. 9 plus 4 is 13. 13 plus 13 is 26. So our final answer would be 26 radical 3. So who's right? No. Do y'all know who this is? This is Toad. Okay, cool. All right, adding and subtracting radicals. We're going to keep working on this. Today, we're going to focus mostly on subtracting. Sometimes this gives us a little bit of an issue, especially when we have negative numbers. So we're going to subtract the radical expressions below, write the answer in simplest form. Pay attention to the fact that we have a cube here and a cube here. Okay, so now instead of breaking it into pairs, how many things are going to be in a group? 3. Okay, so let's do this one together. So let's look at the numbers only first. 54. What are factors of 54? Factors of 54. So best way to do this is either to use Desmos and go in and type 54 divided by x, pull up the table, and then you get all your numbers. Huh? Okay, so 26 times what gives me 54? Come in. Hey, friend. Okay, so 18 and 3. What does 18 break down into? 9 and 2. And what does 9 break down into? 3 and 3. Okay, so take a second, write that down. And remember, we're trying to make a group of 3. Okay, so we're trying to make a group of 3. So what number do I have that is represented 3 times? 3. Chris, make sure you come get this password. So we're going to take that 3 and we're going to pull it out to the front. And then what are we left over with inside the radical? Okay, so looking at our numbers, just 2, right? Okay, we haven't done with our variables yet. Okay, so what I did is I broke down the factors. I found my group of 3. I pulled it out to the front by multiplying it by what's out front. Okay. Now we've got this x to the 3rd. Yeah, that's a 2 at the bottom. So sorry. I gotta remember, I gotta raise that up. So now we got our x's. We want to make a group of 3. How many groups are we gonna have? 1. we're going to pull that x to the outside. So it's going to be 6x cubed root of 2. Now, unfortunately, we're still not done. We've got to break down this guy over here. So what are factors of 16? 8 and 2. What are factors of 8? 4 and 2. What are factors of 4? Okay, we need a group of 3, right? So 1, 2, 3. So we're going to pull that guy out to the front. Now there's an x chilling out front. So we're just going to put a 2 in front of the x. With me? So negative 2x. We're going to say the cubed root. And what are we left with on the inside? Just a 2, right? Chris, you good? Okay. Now we're still not done. Still not done. Okay. Are they the same underneath the radical? Yes. So that means I can combine them, right? So what's 6x minus 2x? 4x. I'm going to write this over here. 4x cubed root of 2. That's our final answer. Okay. So we're going to break down this 8 into probably 4 and 2. Break down 4 into 2 and 2. And we want groups of 2. So we're going to take out a 2, multiply by up front. 9 times 2 gives me 18x. And what are we left with? A 2. And they also had this little x right here. Can I make a group of 2 with that x? No, so he's just going to chill inside the radical. Okay. On the next one, we're going to break this down into, you could do 9 and 2, or you could do 6 and 3. That's fine. We're going to break this down into 3 and 3. We see a pair of 3s. We're going to pull him out front. And so that's going to be 24. And inside, 8 times 3. Okay. And then 2 is going to be left underneath the radical. We've got 3 x's. So how many groups are we going to have? 1 with 1 left over. All right, 72, that can be broken down into, you can do 8 and 9. I'm going to do 2 and 36. I'm going to break it down into 6 and 6. Yesterday, I had some people not understand the concept of if you get pairs at the bottom, you don't have to like keep breaking it down. Like if you don't want to break this down into 3 and 2 to the very end, I see that there's a pair of 6s. Do we see that? You get the same thing. So you should have ended up with negative 6 square root. 2 is going to stay on the inside. And then I've got 3 x's. So I'm going to have 1 group on the outside and 1 on the inside. Everybody okay with that? Now, if you would have broken this down into like 3 and 2, you still get the same thing. So if that makes you more comfortable, that's okay. I personally like to make my life easier. Okay. We're still not done. Okay. Are all of our things the same underneath the radical? Yes. Now, sometimes it's not all going to be the same. Okay. And we'll talk about that scenario in just a second. But since they're all the same, we're going to take the outsides. What's 18x plus 24x minus 6x? So what's 18 plus 24? Use your calculator, please. 18 plus 24 minus 6. Okay, so this is going to be 36x square root of 2x. I'll write it over here. 36x square root 2x. Ta-da! We good? Okay. If this wasn't the same, like, let's say this last one was like 5x instead, you would just have combined these two and then brought this one into the final answer. Okay, again, we're going to practice some of those in just a second. So, determine the perimeter of the triangle shown. Simplify as much as possible. Yesterday, we talked about this conversation. What does this mean? The same as this guy. Okay, so this is going to be 2 radical 98 x to the third. Can you take a moment? Can you simplify each side and then add them all up? Okay, so simplify each side, add them all up. Take like 3 minutes. That's what it is. All right. Okay, so is this guy already broken down? Yeah, so he's good. All right, so over here, we've got 2 square root of 98 x cubed, right? Okay, so what are factors of 98? 7 and what? 7 and 14. Okay, and then I can break 14 down into 7 and 2, right? Okay, somebody yesterday asked me this question too. They were like, well, what do I do with the 7? Well, can you break the 7 down into anything except 1 times itself? Okay, so that's where like the end of that branch is, right? Okay, so now we've got a pair of 7s. We'll pull this guy out to the outside. So that's going to give me 14 with a 2 left over on the inside. Notice how I only look at the ends of the branches. If you're not super organized, now is the time to start getting there, okay? Now, x cubed, I have 3 x's. How many groups am I going to have? 1 with how many left over? Okay, so this guy is going to be 14x square root of 2x, and this guy is going to be 14x square root of 2x. So we're going to put it all together, and that's going to give me 14x square root of 2x plus 14x square root of 2x plus 3x square root of 2x. Are all the radicals the same? Yes. So then I can add the junk on the outside. So what's 14 plus 14 plus 3? 14 plus 14 plus 3. 31. So it's got 31x square root of 2x. How many of y'all got that right? Yes, we're moving in the right direction. Okay. So let's see what you got. So most frequently answered was, I got x square root of 2x, or I got 5x square root of 2x. That was like the most common answer. So let's kind of go through like, what is the answer? So if I break this down into 16 and 2, I'm gonna pull these, so 4 and 4. I see I got a pair. I'm gonna pull that out to the front. So 8x square root of 2x. Notice how I keep that x underneath? Because I can't pull him out, right? Go ahead. Okay. Well, that's all right. On this one, we got 9 and 2. So that broke down into 3 and 3. So we're going to pull that out to the front. And so that's going to give me -3 square root of 2. I've got 3 x's. Here's a group. Here's another. When I simplified, I got 5x square root of 2x. You're saying that because this wasn't here? Okay. So then we should have gotten -x square root of 2x. Did the rest of you do that as well? Yeah, okay, I see y'all. Okay, so some of y'all just put x up in the front, and some of y'all just put 2x. Okay. So, with that being said, though, I'm glad that we kind of have majority are kind of in the same area. That's good. Okay. So, what I'd like for you to do is you're on that Jake's Farm thing. There's a couple of y'all I just need to speak with about some stuff. So if I call you up, just come sit with me. We're gonna have a conversation. You're not in trouble. I'm just trying to help you. Okay. This guy. Why? because it's not a repeated decimal. Okay, cool. Non-repeating. Okay, you could have said pi because it's like a shape, not a, or a Greek letter, not a number. Okay. All right, so we're going to talk about why the sum or the product of two numbers is rational or irrational. Okay, do we know what the word sum means? To add. Do we know what the word product means? To multiply. If you didn't know that, I know those are from like elementary school and you've heard them before, but if you don't know that, I need you to get comfortable with those words. Okay, so sum means to add, product means to multiply. So if you see those words, that's what that means. Okay. All right. Lord Almighty, there's so much. Okay, here are some examples of integers. So positive or negative numbers. They're whole numbers, okay? The sum of two negative integers is positive. Is that always true, sometimes true, or never true? Okay, so let's think about this. If I take two negative numbers, give me two negative numbers up here. -25 and -10. And it's asking for the sum. So what are we going to do? Add. So what's -25 plus -10? You can use your calculator. Negative. Ooh, okay. So we got to be careful on negative numbers. If it has the same sign, so they both have negatives, what's 25 plus 10? 35. And then throw the negative in front, right? So this will be -35. Okay. So is that a positive number? No. Okay. So what we're trying to do is we're trying to create a scenario where it proves this statement to be false or to be true. Okay. Can we use a couple other numbers? What if we did -1 plus -2? What does that give us? -3. Is that a positive number? No. So is this ever true? Is it true that if you add two negative numbers, you're going to get a positive number? No. So this is never true. Do we see it? Okay. All right. Now on the next one, the sum of two integers is another integer. Is that true? So let's take two random integers. Pick two from up here. 40 and 5. So 40 plus 5. Oops. Disappearing. 40 plus 5. What does that give us? 45. Is that an integer? Yeah, that's another integer. What if I took -25 plus +5? What does that give me? Okay, is that another integer? Yeah. Remember, integers are whole numbers. They can be positive, they can be negative. Integers are whole numbers, positive and negative. Right. Cool. So is this true? Is it always true? Yeah. Okay, always true. Okay. So on this next one, the product of two integers is negative. The product of two integers is negative. So give me two integers from here. 5 and 9. Okay, so 5 times 9 gives me what? 45. Is it negative? No. Okay, let's see if we can make it possibly true. Product of two integers is negative. What if we took -10 and multiplied it times 5? What does that give me? -50. So we've got one that's positive and we got one that's negative, right? So this is sometimes true. Sometimes true. Okay. On the next one, the product of two integers is another integer. So if I take, let's say, negative 25, and I multiplied it times 0, what would I get? 0. Can you give me another one? What if we did negative 10 times negative 2? What does that give me? A negative times a negative is so 20, right? Is that an integer? Yeah. So that's going to be always true. You're going to calculate the area and the perimeter. Remember, perimeter is you add, and then the area is you multiply the sides. This little hash mark means that all sides are equal. Okay, so you're going to add them up, all sides, that'll be the perimeter. Tell me if it's rational or irrational. First things first, let's do perimeter. Okay, you need to simplify this junk at all? No. Like you could break this down, but no pairs pulled out, right? So I'm going to add 5 square root of 6 plus 5 square root of 6 plus 5 square root of 6 plus 5 square root of 6. And they all have 6's underneath. So what's 5 plus 5 plus 5 plus 5? 20 square root of 6. Is that rational or irrational? What'd you say? Irrational. Why? Okay. So when we plug this into our calculator, we get like some decimal that doesn't repeat, right? It just keeps going on forever. That makes it irrational. Okay. If there's like a square root and then a number underneath, it's going to probably be irrational if it's not a whole number. Okay. Cool. Whole numbers are rational. Yeah. Irrational means that they keep going on forever. It's like if your boyfriend or your girlfriend is like nagging you and they're being irrational and they're talking about the situation forever, right? Wow, that was a far stretch. Okay, area. Let's talk about area. Listen, I'm just trying to get something to stick. We're gonna multiply this junk. What do we know about multiplying radicals? We multiply the outside and then the inside. All right, so what's 5 times 5? 25. And then what's 6 times 6? Can we take the square root of 36? Take the square root of 36. What do you get? 6. So this will give me 25 times 6. What's 25 times 6? I don't know this off the top of my head. You're going to have to look it up. Actually, it's like 150. Yeah, boom. Still got it. All right. Is that rational or irrational? Rational, because it's a whole number. Good. This stuff does not go away. And they throw it at you for no reason. Like, I don't know if I've ever been asked if it was rational or irrational in the math world besides this. Okay. Yes, it's not the best thing, but here we are. Okay, so show these two statements are incorrect. That means that you're giving me an example of why it doesn't work. Give me an example of why it doesn't work. Okay, so take a second. If you can prove these two statements are incorrect, okay, you're coming. Okay, so y'all did the exact same thing I would do when it comes to these problems. I'm assuming that half of y'all didn't put an example down on your paper. So I know these are tough. These you have to kind of play with numbers. So the sum of two irrational numbers. Give me an irrational number. Pi, okay? So pi plus another irrational number. Okay. Let's do like square root of 3, right? So if I added these two together, would this be rational or irrational? Irrational. Okay, now we're trying to prove that these are incorrect, right? So this proves that it's right. But what if we have something like square root What if we did like square root of 4? No, because that would be irrational. Anybody come up with anything? No. Square root of 7 plus what? Okay, so when we add these together, we're still going to get square root of 7 plus the square root of 3. Does anybody come up with a solution? Okay. Everybody's got a phone, right? Or has access to a computer. I want you to look up on your computer, the sum of two irrational numbers is always irrational examples. I want you to look it up. And see if you can come up with an example of why this is an incorrect statement. When you look this up on Google, okay, because again, this is kind of hard to like have already ingrained. This comes up. So let me explain what they did here. So if I have 2 plus the square root of 2, and then I have plus 2 minus the square root of 2. These are two different irrational numbers, right? Now, we can only combine things that are the same, right? So for instance, I could combine this 2 and 2. What does that give me? 2 plus 2 is 4. Now, we've got the square root of 2, and then we've got this negative square root of 2. So there's a 1 out here, right? And there's a 1 out here. What's 1 minus 1? So these guys cancel. So this gives me a 4. It gives me a positive number. This is rational. Okay, I know this one's a little tricky. Here's what I need you to do. On your test, which is coming up, it's actually on Tuesday. Yeah. Okay, on your test, this is going to be a question. It's going to say, give me an example. This is the example you want to know. Okay, and I'll go over this before the test because I know this one's a little tricky. Okay. Now, this next one, not too bad. Product of two irrational numbers. Is it always irrational? Well, what if we did square root of 2 times square root of 2? What do we know about multiplying radicals? We multiply the outsides. That gives me 1. Multiply the inside. What's 2 times 2? And we know the square root of 4, right? Okay, that's a rational number. Yeah. This one's a little easier to kind of pick up. If you multiply two radicals that are the same number, you get a rational number, no matter what you do. Cool? Okay, again, I know this is tricky. We're going to go over this more on Monday. Okay,